The next type of rational function we're going to look at is a little bit different from what you've seen in the previous video. You may notice, hopefully you notice right away, what's different is that there are two x's in this case. There's an x in the numerator and an x in the denominator. So some of the things we just discussed will no longer apply. Some of them still are true. The biggest thing that's still true and will always be true of rational functions is that anything that makes the bottom equal to 0 is going to be our domain. It's going to tell us what our domain is and tell us what our vertical asymptote is. We can never divide by 0, and so that's going to remain the same. And so the first thing that I like to do is I either think about, in my head, what would make the denominator equal to 0, or actually solve that equation, set the denominator equal to 0, and then solve it. If I do, I add 3 to both sides, and I get x equal to 3. What that tells me is what my domain is. In this case, x equaling 3 would be really, really bad. And so I'm going to say my domain is that x cannot be equal to 3. It's all the real numbers except 3. If I were to plug in 3 for x, 3 minus 3 is 0, and I can't divide by 0. Like I said, that will also tell us the equation of our vertical asymptote. It's going to be at x equals 3. There can be no graph there because I cannot plug in 3 for 0. So let's go ahead and draw in that vertical asymptote. So a vertical line at 3. There'll be a gap in the graph right there. Okay, so that part was old. What's new in these problems is how we find the horizontal asymptote and also the range. When you have an x in the top and bottom of the fraction of the function, all we're going to do is cover up and divide the leading coefficients, the numbers in front. So for example, oops, let's get that out of there. For example, this x has a 1 in it. I'm going to cover up everything except the numbers in front and just divide them. 2 divided by 1 is, of course, 2. And so that tells me my range. It tells me what y cannot equal. So y can be all numbers except 2. It also tells me the equation of the horizontal asymptote. Y is equal to 2. So that's going to be what we do differently when we have an x in the top and bottom. And so there's going to be the equations of the two asymptotes. That's going to be what defines the shape of my hyperbola. And so once I have that done, seeing that both the numerator and denominator are positive, that's going to tell me I'm in this upper right quadrant. So I'll draw one branch of my hyperbola with arrows approaching the axes, and the second branch will be down here in the lower left. Again, I don't care about points. If you want to be more accurate, or if your other teacher out there is telling you to be more accurate, take a look at the table on your calculator and you can find more points or any points if you need to be more accurate. And just one quick piece of advice before we look at one more example like this. If you are ever graphing these on your calculator, make sure you use parentheses or on both the numerator and denominator, or it will not work. All right, let's take a look at this. Again, I've got an x in the top and bottom, so this is one of our newer types of problems. I'll walk through this example with you. However, if you think you have the idea, this would be a great time to pause the video and try on your own. So first thing that I'm always going to do with a rational function is figure out what would make the bottom equal to 0. That'll tell me not only my domain, but also my vertical asymptote, and that's always going to be true for every type of rational function. So setting the bottom equal to 0, many of you hopefully can do this in your head, otherwise this is how you would work it out. I'd add 4 to both sides and divide both sides by 2 to get a final answer of x equal to 2. That's my domain. Well, more specifically, that's what I don't want x to be. I do not want x to be positive 2. If I plug in 2 for x, 2 times 2 is 4, subtract 4, and then I'm dividing by 0, and I cannot do that. The equation of my vertical asymptote is also determined. That's going to be x equals 2. So let's go ahead and draw that in. I'm going to have a dashed line through my graph right there. I will not have a graph at that point. I cannot divide by 0, and so x cannot be equal to 2. Once again, like our last example, to find the horizontal asymptote when there's an x in the top and bottom, cover everything up and divide the leading coefficients. So forget about anything after that and just divide what's in front. 3 divided by 2 is just 3/2, or 1.5 if you love decimals. So that tells me my range. Y can be all the real numbers except 3/2. And it also tells me the equation of my horizontal asymptote. Y is equal to 3/2, or 1.5. So if I draw that in, I'll count up 1, and then a little bit more, about halfway. And that's going to be the equation of my horizontal asymptote. So those will determine what the shape of my hyperbola is going to look like, or rather where it's going to be located. Once again, because the x coefficients are both positive, I'm going to be here in the upper right section. So there's one branch of my hyperbola. You can graph it on your calculator if you want points, otherwise a sketch is fine with me. And then down here will be your second branch of the hyperbola.